Hello students, today we're just going to be covering limits and limits when x tends to infinity, which basically means we're understanding the end behavior of certain functions. So we're simply covering end behavior of functions, and we're going to do odd degrees, even degrees, let's say positive coefficients and negative coefficients. So let's say I have f of x, which equals to, okay, let me fix this really quick. Okay, there we go. Let's say f of x equals to 2x cubed minus 4x4 plus 2x squared. Now, is this function arranged properly? No. Why? Because the highest degree should be the leading term. If you watched the powers video, you would have understood this. So this is negative 4x4. Then you write down 2x cubed plus 2x squared. Now let's say we're finding the limit of this function when x tends to, let's say, infinity. To find the limit of this function when x tends to infinity, we simply plug in infinity into the leading term. So in this case, plugging it in, what do we get? We simply get negative 4, which is multiplied by infinity raised to the power of 4. Now always imagine infinity as a very large number. Let's say it's 1 million. If I have 1 million raised to the power of 4, well, that's going to be a larger number. But if I multiply it by negative, what happens in this case? So let's say this is like 1 million, right? Then it's raised to the power of 4. I don't know. Let's say it's 1 trillion now. So 1 trillion. Is this how you write down trillion? Is it double L? I don't know. You multiply it by negative. What do we get? We get negative of whatever that number is. So it's a very large number, but it's negative, so now it's negative infinity, if that makes sense. Now, let's do limit of x tends to negative infinity of the same function. Remember, we only take the leading term, which has the highest degree. So now I have negative 4 multiplied by negative infinity raised to the power of 4. So what do I get? I get negative 4 multiplied by a really large number, which is infinity, because negative 4 is raised to 4. That gives us an even. That since we have an even power, it gives us a positive sign. So negative 4 times infinity is simply equal to negative infinity as well. Now, what if we have f of x, which equals, okay, you need to understand these keywords as well. So this function is decreasing, right? Because and it's decreasing without a bound. You need to memorize this. So without a bound, 1 second. Okay. Means that there's an infinity going on. So without a bound means there's an infinity. And if it's a negative infinity, then it's decreasing without a bound. And if it's a positive infinity, it's basically increasing without a bound. All good? Very simple. Now, what if I have f of x, which equals to negative 2x cubed? I'm not going to write anything else. That's it. Let's say I have limit of x tends to negative infinity. Pause the video, try and solve this on your own. For f of x, what do I get? I simply get limit of x tends to negative infinity of negative 2x cubed, which is equal to negative 2. You got negative infinity raised to the power of 3 which is simply negative 2 multiplied by negative infinity. Negative and negative do cancel out. You're left with infinity, and that's it. What if I have limit of x tends to infinity of the same exact function, so negative 2x cubed? What do I get now? I get negative 2 multiplied by infinity cubed, which is simply negative infinity. Now, yeah, that's pretty much it. And I just want you to know that with odd functions, we have f of negative x equals to negative f of x. This has nothing to do with what we just did, but just understand that odd functions, you got this going on. Since we're not going to come back to this ever, and let's say we have, with even functions, what do we have? We have f of negative x, which equals to f of x. And please, 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 do not mess up on this. If you see an odd degree, let's say a function f of x equals to 2x cubed minus x squared, this does not mean that this function is an odd function. This may not be an odd function. Not just because the degree, the leading term, has an odd degree means that the function is odd. No, you need to test this out. Same with even functions. If I have f of x equal to 2x squared minus x, this is not an even function. Not just because the degree is 2 means that this function is straight away an even function. No, that's not how it works. You need to test it out as well. And yeah, that's pretty much it for this video. It's not going to be a tedious video, I would say. It's very simple. Just take your notes. And yeah, that's pretty much it. Thank you.